Hello, my name is Jeremy Walker. I am a Data Services Librarian and a member of the library's Research Data Services Team, otherwise known as RDS. The RDS team has organized and will be judging the undergraduate Get Data Lit contest. My colleagues on the RDS team and I have created some sample presentations that should give you a sense of the kinds of topics you may want to present on and the depth and quality of research and presentation materials that we expect to see from contestants. If you have any questions about the Get Data Lit contest, you can find all of the information on the RDS website, library.gsu.edu/data. With that in mind, let's get started with my presentation that's titled Confusing Cartography and Misleading Maps. On October 1st, 2019, President Donald Trump sent out a tweet containing a map of the United States. The map was segmented by county, and each county was color-coded, presumably according to the election results from the 2016 presidential election. The map was also overlaid with the text saying, "Try to impeach this." Now, I am not interested in talking about politics today. I am recording this presentation in February 2020, and if you are listening to this, you and I already know how the recent impeachment proceedings in the United States have played out. Rather, I want to talk about the map itself. Maps can be powerful and insightful tools for communicating information and data. That's why I assume Donald Trump used it as well in his Twitter feed. However, when I saw this map, a few things struck me as off or weird. So for this presentation, I want to take a deeper dive into investigating this map and asking questions like, is this map accurate? What exactly is this map trying to communicate? And based on the answers to those questions, are there better ways to communicate that information, better ways to visualize it? Beyond my own curiosity, maps and geographic literacy are important subjects unto themselves. As discussed in a CityLab article from 2015, spatial and geographic literacy in the United States is not very good, and there are a myriad of ways that maps can be deceiving or misleading. Returning to our map, the first question we need to ask is this map accurate? At first glance, it is very hard to know. There's a lot of information missing, such as titles, labels, legends, a date. This type of information usually lends a lot of credibility and reliability to a map by very honestly communicating information. But since that's not there, we don't know for certain. We can make a lot of assumptions, given the context in which this map appears. It was tweeted out by the President of the United States. It's color-coded according to the traditional colors associated with the two main political parties. However, we honestly don't know because a lot of the information that usually comes with a map is missing. After a little bit of research, I was able to determine that this is indeed a map of county-by-county election results from the 2016 presidential election. Knowing that, I used Social Explorer to test and evaluate whether or not Trump's map is accurate. Social Explorer is a robust demographic data and mapping tool available via the GSU library website. Although the maps are very similar, if we look very closely, not all counties are presented in the same color. So it seems that one of the maps is wrong and inaccurate, possibly both. Given that Social Explorer's business model hinges on them producing reliable and accurate data sets and maps, I'm inclined to believe that the Social Explorer map is accurate and Donald Trump's map is not. As it turns out, the map tweeted by Donald Trump is in fact not accurate. The map was produced very soon after the 2016 presidential election, but before all the votes from all counties were verified. The original author of the map actually updated the map to reflect correct election outcomes as the data became available. How and where Donald Trump acquired the earlier inaccurate version of the map is unclear. For further reading into this map, feel free to check out the Snopes.com article cited in the slide. Now, even though this map is inaccurate, we can still ask about its purpose and try to understand what messages this map may be trying to communicate. By using this map, is Donald Trump trying to send a message about the odds of him being impeached as a matter of politics? Or is the purpose of the map to more broadly communicate a sense of Trump's popularity with the American populace? It seems unlikely that the message pertains to the impeachment process itself. After all, impeachment is a process initiated by Congress. Therefore, if it's the process that's the primary focus, then a map segmented by congressional districts may be a more accurate visualization of the data. However, a district map also makes it appear that there is significantly more blue areas than what is indicated in Trump's original map. Furthermore, the Senate is the body of Congress responsible for voting to remove an impeached president from office. However, the color coding for that map shows an even less conclusive outcome than the one presented by Trump's. With that said, we can probably infer that the map is not intended to communicate anything related to the impeachment process itself, but rather is meant to convey a sense of Trump's popularity in the United States. This is where we get into the core problem with Trump's map, and what are called choropleth maps more broadly. In short, choropleth maps, or color-coded maps like Donald Trump's, confuse and conflate geographic space and density with other measurements of value. More information on this can be found in a book owned by the GSU Library and available for digital download through the online catalog by Morales. The whole book is focused on data visualization, but in particular there's a chapter focused on spatial structures, and including maps. And from that we're going to draw a lot of our conclusions for the rest of this presentation. So let's consider the more accurate version of the map Trump was trying to use. Just a reminder, this map came from the Social Explorer website. To grossly oversimplify, we can view maps in much the same way that we view traditional XY graphs. In this case, X and Y are simply longitude and latitude. Now, if you were looking at an XY graph like the one that's on screen, you might correctly infer that the density of dots in several regions suggests that the data has a lot of observations in particular areas, and that there might be a greater importance or value in those densely populated regions of the data. Additionally, if you saw a scatter plot or an XY plot where some of the dots were larger in size, you might again correctly infer that they contain extra value or extra information as represented by the magnitude of their size. We could go further. We could change the shapes from dots to X's. We could add color coding patterns. There's a variety of ways that on a simple XY plot we could communicate a variety of different pieces of information. Returning to the 2016 election map, you might begin to see how the map could be misleading or misrepresentative. Instead of dots like on our previous XY plots, each observation on this plot, the longitude-latitude plot, is represented by the shape of the county rather than a simple dot, and they happen to be organized in such a way that they fit together. However, the relative size and density of the red dots versus the blue dots implicitly gives us the impression that there's a lot more red than blue, and consequently we might infer in United States political language that Donald Trump has a lot more popular support than not. Or at least that's what this map is implying by its use of red versus blue and the density and distribution of counties. But if we stop to think about it, counties are probably not good approximations of people and therefore not good approximations of popularity. Some counties, after all, only have a few dozen residents, whereas counties like Los Angeles County has a population of 10 million. The implied message of this map breaks down further if Alaska is scaled closer to its actual size. While the implied message that there is more red than blue, that Donald Trump is more popular than not, is still present in this map, the common knowledge that Alaska is not a very populous state starts to break down that implication and starts to cast doubt on the message that the rest of the map is sending. Ultimately, although I have not asked Donald Trump directly myself, I think we have to assume that the map was intended to communicate Trump's relative popularity within the country. Additionally, we have to conclude that the way this map uses color-coded counties is a severe misrepresentation of the underlying data. This leads us to the final question. Are there better ways that we could visualize this information? Is there a better and more accurate way that we could use maps to visualize Trump's popularity in the United States? The short answer is yes. We could change binary color palettes to gradient color palettes. We could also skew the size and shape of data representations on the map. We could also add additional layers and markers to communicate different metrics and values. The examples generated by Mark Newman are the ones highlighted on screen now. Professor Mark Newman is at the University of Michigan, and these examples, again from the 2016 presidential election, introduce some of these options for improved visualization, such as color gradients and skewing the size and shape of respective counties. And for your information, the maps that are skewed in this way, skewed and morphed, are referred to as cartograms. Now, while cartograms are very cool and impressive, they require a lot of context to understand. If Donald Trump had simply tweeted out a cartogram like the one generated by Professor Mark Newman, I suspect many people would not have understood any component of the message he was trying to communicate. Furthermore, from a technical point of view, cartograms are very difficult to generate without immense technical expertise. With that in mind, let's return to Social Explorer, where we can use its mapping features to simply add new layers and markers to the map in order to represent the data that we are interested in. We will start with a base map that simply shows all of the U.S. counties, excluding Hawaii and Alaska. We can then add bubbles for each individual county in the United States, then have those bubbles shaded according to the percentage of the population that voted for a particular party, and then scale the size of those bubbles according to the size of each respective county's population. Altogether, this gives us a pretty comprehensive view of popular support for each of the two main political parties and the relative size of the populations in any given area. It is important to note that the first map we generated was drawn from the data for the 2016 presidential election. However, the tweet that we were looking at from Donald Trump was sent out in 2019, so it may be better to look at data from a more up-to-date election. In this case, we're going to look at the 2018 midterm elections. Now, Social Explorer only segments the 2018 election data by congressional district. Although it's not perfect, it is still a close proxy for popular support and distributed geographically. When viewed side by side, the maps generated in Social Explorer do not reflect the ideas communicated by the map in Trump's tweet. When viewing the data in a robust, accurate, and visually coherent way, it appears that while Trump and the Republican Party more broadly do enjoy a broad base of support in the U.S., that support is not as overwhelming, nor is it as conclusive as the visual information implied through Trump's tweet. To recap the questions that I asked at the very beginning of this presentation, is this map accurate? What is this map communicating? What is Trump trying to communicate by using this map? And are there better ways to visualize this information? At its core, the original map Trump sent out is factually inaccurate. Some counties are shaded with the wrong color. Furthermore, and arguably more importantly, the message that this map sends misrepresents and conflates geographic space, size, and density of things like counties with the distribution of people and their opinions and voting patterns, giving the sense that Trump has much more popular support than he actually does, at least according to election data. Furthermore, this is probably a rock-solid example of fake news or hashtag fake news, but that might be a discussion for another day. And then lastly, the question we asked, can this be improved? The answer is definitely. Maps like this have a lot of room for improvement, and there's a lot of resources out there that can help with making better maps. And to quickly wrap up, these are just a list of the references I used throughout my presentation. If you are very interested in mapping and spatial data and visualizing such information, I strongly encourage you to check out the book by Morellis, and also, as a good starting point, read the CityLab article by Weissman. And finally, thank you for viewing my sample presentation. If you have further questions about the GSU Undergraduate Get Data Lit contest, please check out the rules at the bit.ly link or find the RDS library homepage where you can find more information. Additionally, you can also email Mandy directly. Her email is on screen, and she can communicate with you about any particular questions you have. Thank you, and have a great day.